Thank you for coming to our session, Water Resources Management Across the Semi-Arid Southwestern United States, Insights from OpenET Applications in California, Utah, and New Mexico. I'm really excited that you all wanted to come see what we have to say. I'm Nick Santos. You'll hear my bio before I give my talk, but before we get started, I just wanted to give a bit of session logistics. So we have 5 presenters. First, Jack Severson's going to give an introduction to Secure Water Future, the project that coordinates the rest of these presentations. And then we'll have 3 case studies, and then at the end I'll talk about some tools that help make one of those case studies possible. So if you're looking in the program and wondering what the order is, it's not what's in there. Jack will show it at the end of his slides. And with that, I'll introduce Jack Severson. So Jack Severson is the Secure Water Future Coordinator. Jack studied cultural anthropology and environmental studies, and his introduction to the water world started in California as a whitewater raft guide, giving him practical insight into water management and climate adaptation. So, thanks, Jack.
Good morning, Nick. Thanks for the warm introduction. Lovely to see everyone here. So I'm Jack. Happy to see everyone once again. Cool. And so I'm working as a coordinator as a part of Secure Water Futures, and I'm going to tell you a little bit about it right now. So this project delivers novel tools and techniques for a water-stressed region, enabling thriving agriculture, healthy ecosystems, and community resilience in an uncertain climate future, from the field to regional scales. During the project's 5 years, our goal is to understand, enable, and envision water management strategies empowered through data-enabled decision-making for agriculture and ecological systems in the southwestern U.S. Our transdisciplinary team works with growers, irrigation districts, and ecosystem managers to adopt and adapt climate resilience strategies, train the next generation of transdisciplinary practitioners, and produce an online dashboard for data-driven decision-making. By bringing together hydroeconomic and life cycle assessment with localized water accounting and regional climate projections, the project goal is to evaluate and enable water trading for climate resilience in agricultural and ecological systems in the southwestern U.S. So, who is SWIFT? This is all a part of SWIFT. We have a lovely, unique team that all contributes really powerful work on all ends. There are currently over 80 members of the Secure Water Future team. These project affiliates represent various career stages from full professors and vice presidents of organizations to undergraduate students. Members of the Secure Water Future team focus on issues relevant to California, Utah, and New Mexico, with applications to the semi-arid western U.S. Secure Water Future aims to improve agricultural and environmental water resilience. Funded by the U.S. Department of Agriculture, this project combines the expertise of researchers, extension specialists, and educators working across California, New Mexico, and Utah, with applicability to the Western U.S. and beyond. Our network also includes the expertise of the USDA Southwest Climate Hub and regional extension grower networks to co-create climate change adaptation in the Western U.S. So we want to thank our network that helps us do what we do and supports us in every single way. This project is funded by the USDA National Institute of Food and Agriculture. So now I was going to kind of show you the agenda for the speakers following. I'm going to pass the mic over to Nick, who will introduce Alfonso and the rest of the team. Thanks so much.
Yeah, and while we're transitioning, just noting, thank you all for being willing to stand in the back. There are 2 seats up front here. You're welcome to come grab one of them. I see another one there. So there are 3 more seats here if people want to snag them. And as I mentioned, but since we still have people trickling in, this is the presenter order. It's not the same as what's in the program. So we're going to start off with Dr. Alfonso Torres-Rua. on identifying Utah water conservation opportunities by farm water balance and OpenET data in just a moment. So, Alfonso is an associate professor at Utah State University and specializes in irrigation engineering and remote sensing. His research focuses on agriculture, water balance, and precision irrigation. He's actively involved in the USDA-funded Secure Water Future project, this one, which aims to create information and tools for water conservation and water trading. Within the SWIFT project, his primary contribution lies in identifying opportunities for water conservation and agriculture, spanning from field to water canal companies. Thanks, Alfonso.
Need to find my presentation. Okay, good morning, everybody. It's so wonderful to be out of the cold Utah. It's good to be out of the cold Logan weather to a warmer environment here and see so many familiar faces and new faces here involved in, with OpenET. Well, this presentation is an application of OpenET and remote sensing information to identify where are the opportunities for water conservation. This is still a work in progress, and I want to show you how far we have made progress on this topic. We are part of the SWIFT project, and my area of expertise and my work is related to measurements, is how we make sense or how we can use ground information and remote sensing data to identify such opportunities in water conservation. Now, we have to define water conservation here, and this is the concept we have taken here, is the amount of water that typically is allocated for agriculture that is applied or is reused in other environments or in other agricultural applications, but not on the same location, the same geographical location. Now, the water conservation is going to have a different level of importance depending on dry or wet years as the seasons go. In dry years, producers are very important in water conservation and efficiency. They will maximize and they will pay a lot of attention on how water is applied in the field in order to maximize profitability. In wet years, it's the opposite. We will see other water user groups encouraging producers and farming to do water conservation activities as much as possible. And this is something that is happening very frequently in Utah. We have a major problem with the Great Salt Lake, has descended to very dramatic levels, and society is encouraging producers to be as efficient in water use as possible. Now, water conservation, how we can measure water conservation, how we can identify these opportunities. Well, a textbook concept will be to compare water used by the crop versus the water applied into that field. And this is a basic metric that can use and identify that magnitude that potentially can be quantified or can be saved towards conservation. There is a much larger or complex approach that means solving the water balance and identify the magnitudes of the residual. In the residual, we're talking about runoff, deep percolation, and capillary rise. That means we have to identify all the other components of the water balance in some way and estimate this number, this residual number, and compare this number to a threshold that is related to the irrigation system and the irrigation conveyance system efficiencies during the season. Now, water balance approach, and this is a textbook water balance approach. Now, nowadays, with the development of instrumentations and automations, For individual fields, it is possible to implement or to instrument fields that can track most of these water balance components. But think about producers that handle 100 center pivots or a large canal company. The increase in cost and management of these instrumentations becomes more complex. There, we have over the years been building tools or building sources of information that can give us can describe these different water balance components at different levels of accuracy. And nowadays, with OpenET, we're having access to one of the major components, what is evapotranspiration. In our analysis, we're preferring an approach that deals, rather than dealing with absolute soil moisture values as part of the water balance, with soil moisture depletion. This is done due to two reasons. One, it's very difficult to model soil moisture conditions above field capacity. The relationship between atmospheric or weather and surface condition with saturated conditions is not strongly related, while conditions from field capacity and lower soil moisture values are driven by conditions or factors affecting the water movement. So field capacity or the soil water depletion is our preferred method to estimate to implement the water balance. And again, we're using the same pieces of information, spatial information that are available to all of us. Our area of study is located in the southern part of Cache Valley that comprises of 3 canal companies fed by the same reservoir storage. And for these 3 canal companies, we want to identify or we want to quantify the residual from the soil moisture water balance. So we have OpenET maps that can describe the variability of ET at monthly, seasonal, and nowadays daily scale across these 3 canal companies. OpenET is also able to provide us grid-met precipitation estimates, which in Utah during the growing season, we currently assuming is very similar to effective precipitation, and we thought today in the plenary that OpenET is also looking to do a better job quantifying that effective precipitation. And we have irrigation data coming in the form that from flow meters installed in different locations in the canal company. And this is going to be typical in Utah. Not every field is monitored in terms of water application. Typically, it's used at the main canal entrance or inflow location, and some key locations across the canal network. So if we are going to calculate this water balance and estimate the residual, we need to calculate this soil moisture, this delta of soil moisture depletion over a period of time. And in this case, we're considering a monthly time scale. So it's very hard to model these changes in soil moisture, and there are hundreds of or multiple papers in the literature that have tried to deal with this issue. We found a paper recently published by Kiseka that summarized some of these classical models that look to estimate changes in soil moisture, and we apply it to our data. And unfortunately, they didn't work. Then we tried to go one level up and try some nonlinear modeling with genetic programming and as in a software package called Eureka. It didn't work either. So as a last resort, we consider the use of machine learning, specifically the random forest, to model these changes in soil moisture depletion over a monthly period of time. Now, modeling modeling these changes in soil water storage is very difficult for, for one major reason. There is not enough data, and this was just highlighted in the plenary again. In Utah, in the entire state, we have only one site where there is a unique combination of eddy covariance measurements along with a soil moisture profile from topsoil all the way to the groundwater table that provide us with that information, the variability of soil water storage over multiple years. And this is the data that we are using in our machine learning. Now, this is the only site, and for now we're going to consider that this site can approximate what's happening in similar Utah fields. Now, we found out that there is a relationship with crop evapotranspiration and the changes in soil water storage, but also it needs additional help to describe that behavior from occurrence of precipitation and also weather patterns happening during the evaluated month. So here is our preliminary results of these changes in soil water storage using the data that I just described and the random forest. Here you can see variability of the storage depending on the field and depending on the month. We see that in the June month, we have an effect of water leaving the system, in this case due to evapotranspiration and the reduced amount of irrigation that happened during this month. While in July, we see larger inflows or inflows being larger than the outflow, and this is because of the irrigation happening during this month. In August, we see a transition between the effect of evapotranspiration and irrigation as the management of the field are changing over the season. So this is for us something that we want to continue refining this model. We can see variability on changes in soil water storage, allowing us to approximate that residual component that we want to identify per field and per canal company area. Next steps. Well, we want to complete this quantification of the residual and establish that threshold. We want to assess, we want to identify like what we call it the low-hanging fruit opportunity for water conservation. It means what are the months where water conservation is more suitable and easier to do if producers will have that information on hand. And we want to extend also this similar model across the state of Utah because we have a climate gradient, and that means the changes in weather conditions are going to affect the magnitude and the water conservation opportunities across the state. Additionally, we want to include these calculations and put it in a more software-friendly tool that we call it the JACU tool, which is based on GIS software, ArcGIS Pro software. So producers and canal companies could use this software to run their own internal calculations and assess for themselves these water conservation opportunities. And if times allow us to extend this sort of assessment to other regions like California and New Mexico. This JACU tool software, we have been working on this software, and it looks to combine or to develop this seamless connection with OpenET and remote sensing sources into a toolbox available in ArcGIS Pro where queries can be done or requests can be done to interpret what are potential water conservation opportunity per field and per water canal company. And that's all the information I have for you guys, and I'm happy to answer any questions you have. Thanks.
And we do have time for questions right now, so go ahead. Do we have a microphone that we could pass around in the room?
Over there.
Oh. Hi, Alfonso, I really enjoyed your talk there. What has been the response of the canal companies so far to this work? Are they receptive to it, or skeptical, or are you receiving any pushback? Or
We have a positive and also a concerned response. So positive in the sense that the aperture of water markets or in Utah water banking opportunities will allow them to, in occasions when they have, let's say, excess of water or water that they were able to save, put it towards a lease or to allocate it for environmental purposes like the Great Salt Lake. For that part, they're happy to come up with numbers that can give them an idea how much water they can move from agricultural applications to other uses. The concern from them is that if this is possible for them, that means it's possible for the state. So, and that might come additional let's call it encouragement from this other water users group that can run the numbers and negotiate with them. And at that point is it's still a topic that here in the project, in the Secure Water Future, we're discussing it. How access to more, let's say, specific information will play in the interaction between, let's say, users that have access and have the rights to the water versus other groups that are needing or finds other application for that water and are interested to acquire some of that water. So that's part of the larger vision or the larger scope of this project. And as we develop the tools and the let's say the other components of the project, we will have a more clear response for that.
thank you.
Hi. Have you been working with like the Utah Flex network to try and get more soil moisture sensors connected with all the EC towers in Utah? I mean, right now you said there's only one in Vernal that has both a soil moisture sensor and an EC tower that you can correlate the data to.
So far, I'm coordinating with Larry Hips, who is Eddie Covariance expert at the Utah State University. And so far, this is the only tower that has instrumented soil moistures describing the entire root zone. And typically, it's only shallow level or 1 to 3 feet instrumentation of soil moisture. So that makes us lose opportunity to detect deep percolation. So this is something that if you're working with Eddie Covariance towers to consider as part of your monitoring effort, because understanding not only the weather factors influencing ET and the growing process is important, but also knowing the hydrological conditions of the soil are going to give us a more informed understanding of the water processes in that area.
Thanks.
Great. I think for one more right now.
Great presentation. I had some questions about Yaku tool and the inputs, outputs, and the uses for the tool. Also, if it's open source and you're willing to share.
Yes, we aim to make it open source. We have made significant progress on Yaku tool. What we are working on is in the connection, let's say, with OpenET platform or other online repositories to the Yaku tool software. Our goal is that as the more users or the more people use it, the better for us. We would like to have a feedback and improve this tool. So it's not only for agriculture, it can be used for other purposes too.
Sweet. And the main purpose for Yaku tool is just to like quantify changes in storage, or can you expand a little more on the output results from Yaku tool?
We hope that we can expand it more. And we have a 5-year project. We are in year 3. We're starting year 3. So we hope that we have enough time to implement to implement additional features to Yaku tool. But at least we propose to quantify this opportunity for water conservation historically, like for a site, like as far back in time as OpenET allow us to do.
Sweet. Thank you.
Thank you all, and if you have more questions, I encourage you to find Alfonso later. So, and hopefully we'll have more time at the end.